Very excited to be here. I'm talking about a brand new product from Echelon Corporation called the SmartServer IoT that we're actually announcing this week. So this is sort of very hot off the press. This is actually the first time we've talked about it in public, so this is very new information. So I want to talk very briefly about our vision for the industrial Internet of Things, talk a bit about the new SmartServer IoT, how it addresses that vision, and then talk about a very important part of this introduction, which is a new protocol that we call the IoT Access Protocol. So our vision is that what we believe is required in the industrial Internet of Things is a way to get at today's data. There's a lot of data out there. You see all the data around us, whether they're on LAN networks or Modbus networks or BACnet networks. We need to be able to get that data and get it into new systems that are coming out for the IoT, new data analytics systems, new artificial intelligence systems. So we call the strategy Embrace, Extend, Enhance. So Embrace says we want to get at existing devices. There's hundreds of millions of devices out in the field today, all generating lots of really interesting data that we want to work with. We're not going to throw away those hundreds of millions of devices. We're going to keep using those devices and get their data. But then we want to extend those systems. We want to go to new protocols being developed that you hear about, new protocols like Bluetooth and Zigbee and other protocols coming out in the future, LTE. We want to get at those new devices as well using new protocols, so we call that extend. And then we want to enhance those systems, right? We want to be able to take that data, move it into the cloud, do data analytics on the data generated from those devices, and get new building intelligence out of those networks. So how do we do that? We see this kind of a three-pronged attack, right? So first there's the cloud. The cloud is where we have the data analytics engines running, the AI engines running, and so we want to get the data up there. And where's that data coming from? In the bottom right are the operational technology systems. So these are traditional systems running protocols like LAN, BACnet, Modbus. And so we want to get that data, bring it up to the cloud, and then also embrace information technology systems. So LAN networks running the newer protocols, the IP-based networks, Wi-Fi networks, and also bring the data from those networks up. So we want to have something that brings it all together, and that's really what the SmartServer IoT is about. So Echelon's been doing this kind of work for 30 years. We created LAN technology, and so we have a lot of experience with connecting devices, and so we're using that experience to connect today's devices and tomorrow's devices into these new cloud systems. And what we believe we can target with this kind of opportunity are multiple markets. There's building systems, which is a $50 billion market, growing at 10% compound annual growth rate. So quite a few different kinds of technologies used in building systems. We have embedded systems, a $150 billion market, growing at 8%. And other kinds of systems like semiconductor fab equipment or transportation systems, sound masking systems. And then finally, smart city, smart lighting applications, a $500 billion market growing at 23%, a very fast growing market where we have outdoor lighting controls, management, tunnel lighting controls. So all these systems and all these different markets require the same sort of connectivity. They all have smart devices, smart sensors that you want to get the data out of those systems and into cloud systems. So the way we solve that is with what we call the SmartServer IoT to bridge that gap from IT to OT to the cloud. And so how do we do that? So the SmartServer IoT is up here in the yellow box. That's functionally what's in there, and I'll talk more about that next slide. This is what it looks like. And it's really bringing together edge networking with data management and cloud connectivity. And so within the box, we have native support for today's industrial protocols, so native support for LAN, BACnet, Modbus, built-in services for what those devices need. So services to provision devices, services to schedule them, to collect data from them, to collect data logs, and to generate alarms when conditions happen. And also in the box is the secure connectivity to the cloud, right? So that's how we can get the data from all these devices and push it up into the cloud. And we do that by creating a very rich API layer where that API gives that access to the data but also gives access to essential services and devices, such as provisioning the devices. So it's a very complete open protocol, and that's what's very unique about this solution, is it's a fully open protocol. Any vendor can create an edge server like this that wants to support the protocol. Any vendor can create a cloud service that speaks this open protocol, and you can even embed the protocol directly into IP-based devices. So it's very extensible. We can extend it to new kinds of cloud systems. We can extend it down to new kinds of edge devices. And then within our edge server, we embed a configuration management system that has won awards for being a very simple to use, web-based configuration management system. So blowing up what's inside the box, this is what the box does. And it's built around a common message bus. This is sort of the IoT basis of the system. So that message bus is based on MQTT, a very popular protocol for communicating between IoT devices. But we're sort of really leveraging protocol not only to communicate to the cloud, but also to communicate even within the edge server itself. So the edge server really consists of a lot of services that are built into the box. So services on the top left to do things like scheduling, logging, and alarming. But each of those is a component service sitting on the bus. And then on the bottom, we see connectivity to a lot of different kinds of edge devices, whether they're LAN devices or Modbus devices, BACnet devices, using a very extensible model where developers can add their own drivers for new kinds of protocols if they want. Again, all communicating on that same message bus, right? So we're taking data from a LAN device, for example, putting on the message bus. We could schedule a LAN device from the scheduler, generate alarms from the alarm generator, and do all those same things also for Modbus devices and for MBus devices, or even a locally attached I/O device. So very extensible. Physically, the way we do that is 2 isolated RS-485 ports. We also have 4 USB ports that can talk to then external interfaces to other kinds of networks. And 2 Ethernet interfaces for talking to Ethernet-based devices or Wi-Fi-based devices. And then finally, the connector to the cloud then is taking that same internal MQTT bus and making that same IAP protocol accessible outside the box, talking to a cloud service. And the cloud service can be one that we provide. So Echelon will have a cloud-based service that can talk to the bus, or that third parties provide. So anyone can create a cloud service that talks directly using that IAP protocol to the edge server. So very extensible. And then once we're in the cloud, we can connect those cloud services to other cloud services. So we may have a central service in the cloud that's talking to many edge servers, and then from that central service be talking to a data analytics application, or talking to an AI application, or talking to a SCADA application. So the bus gives us an easy way then to connect many of these edge servers, talking to tens of thousands of devices, then talking to the cloud applications. So what's unique about the new edge server, the SmartServer IoT, is that it has built-in interfaces for the most commonly used industrial protocols, LAN, BACnet, MBus, but also combines that with modern web services. So modern web services based on MQTT and REST, which are very commonly used for IoT applications, very easy to use, lightweight protocols that can be easily embedded into smaller devices or larger applications. And then built-in services that are sort of essential for many IoT systems, things like scheduling, logging, and alarming, built right into the edge server so that you can have local control of a system. Local scheduling, local alarming gives you a lot more reliability than depending on going to the cloud for all these services. We also do have a cloud service called LumenSight Cloud that extends the capability off into a cloud application that you can access then from anywhere. And it's inherently multi-channel, so we can have multiple LAN channels, multiple Modbus channels, multiple BACnet channels, all talking through a single edge server, aggregating all the data from all those systems, and then moving them up into a cloud application. And the server is very programmable and extensible, so that OEMs and integrators can add their own applications that actually run right within the edge server itself and get access to that same bus. So get access to all the data that it connects to, get access to the cloud services that it's connected to. And finally, we have secure interfaces to prevent intrusions and security breaches into all this data. And we have two form factors. So the top form factor is a DIN rail mounted edge server, but we also will sell it as a module that you can embed into your own products. So expandability is very important to us because many installations will require interfaces for different kinds of networks. So the way we do that is through USB interfaces to different kinds of networks, right? So we have network interfaces for some of the most commonly used LAN channels, which are FT, which is a free topology twisted pair, TP1250, which is a 1.25 megabit twisted pair, and Powerline, which is, of course, Powerline communication, typically used in street lighting and smart city applications. So you can have up to 8 of these plugged into the edge server, through USB, and then connect a lot of channels that way. And then we have another module called the IOX for the IO expander that can also plug in through USB and then connect to physical I/O. So simple digital inputs, digital outputs, relay outputs, RS-232 interface, additional RS-45 interfaces. And again, you can have up to 8 of these plugged in as well. And then the user interface to the box is based on the same software that we run in the cloud. So we have LumenSight Cloud for managing many devices across many edge servers. But we take that same software, embed it right within the edge server itself with a web server running in the edge server. So it actually gives you a nice, simple local interface, but that's a very rich, easy-to-use, web-based user interface that's inherently multi-protocol, right? So you can install LAN devices, Modbus devices, BACnet devices through one interface. And since it is web-based, that means the client can be very much multi-protocol. The clients can be a smartphone running a web browser, it can be a tablet running a web browser, a PC or a Mac. It doesn't matter, right? So any client that you run anywhere. And from that user interface, you can look at the data that's been collected from all your devices. You can see data trends of how the data is trending through your devices. Define alarms, so to generate alarms on certain conditions. Look at what alarms have been generated. And then you can customize the interface. So you see there's widgets that are displayed within the web user interface. You can decide which widgets you want to see. So do you want to see scheduling? Do you want to see maps? Do you want to see data logs? You choose the ones that you see within your interface. Excuse me. And it's available in multiple languages so that if you need to translate to German or other languages, you can. And finally, what connects all this together is what we call the IoT Access Protocol. Right? So it's really a rich web services layer that can run in the edge, it can run in a device, or it can run in the cloud and connect the edge to devices and to the cloud. And so it enables developers to create applications that can access any data in any of the devices connected to the edge server, provision and maintain those devices, monitor and manage alarms from the devices, and set and manage schedules for the devices. And applications that use these APIs can run in a variety of places. You can have applications running within the edge server that communicates with the bus through the API, or applications can be running in web clients that are running within a web browser and then communicating with the edge server, and can be running in remote cloud applications, for example, to be doing analytics or AI. So you have a lot of choice for where applications run, but again, using a same API in every case, making it much simpler for developers to create an application that can run anywhere and interact with the device. Right on time. So with that, I want to thank you very much for coming. If you'd like to see more about our new Edge server, we have it running, well, not running, but we have it over here in the corner at the Echelon booth, kind of the other side of that kiosk right there. So I'd be happy to talk to you more. If you have detailed questions, I'll take you through any questions you might have. I think I have a few minutes left here today, so if you have any questions right now, I'll answer them. Anything? Nope, nothing now. Great. Well, come by and see me, and I'll talk to you some more. Thank you very much.
Thank you very much, Rich.